Nazli. I am CFAP2683A. On this video, I will be presenting and conducting one of the non-destructive tests on concrete structure, which is, the test name is Smith hammer test.
Smith rebound hammer is a non-destructive testing and DT equipment originally developed in 1948 by Ernst Smith. The material tested is concrete, mortar and rock surfaces. Some of the features of this equipment is it is portable and lightweight, simple mechanical and digital operation, non-destructive, provides quick result on site, can be used horizontally, vertically and overhead, and rebound value is displayed on digital screen. The application is it will be used to estimate compressive strength of concrete, assessing uniformity and quality of concrete, detect weak zones or deterioration of concrete, quality control during construction, and preliminary assessment before core testing. Some of its limitation is it only can measure surface hardness, not internal strength. The result affected by surface roughness, moisture content, type of aggregates, edge of concrete, and combination of surface. Not reliable for very low or very high strength concrete, and it requires proper calibration and experienced interpretation.
As you guys can see, this is the Smith rebound hammer, and some of the components that have in this equipment is, the first one is the body itself, and inside the body we have latch, spring, hammer, plunger, and the indicator. For this test, I will be referring to the ASTM standard, which is this standard said that we must take at least 10 points in total, which is, so for this test I will be doing at least 12 points at 3 different locations. So the total up will be 36 points in total. Now we will start to do the testing, which is the first procedure that we must do is we must clean up the surface of the concrete to ensure that there will be no error in our reading. So then we put the paper. We start to conduct this test by point the plunger at the first point. Then we put the indicator here, and then we press it to release the plunger. Okay. We start to press it until it hit the bank. Then we press it back. We will take the reading here. So the reading said that it show a 20 readings. Then we will write down here at the first point. So based on 20, so we will start to, we can read the reading here. 20 shown that the compressive strength is 10. We have gained the first reading. That we will be continuing to do the same procedure for the next points until the 12 points, until complete. Then we will change to the different location.
This data shown the final result of the Smith rebound hammer test that have been conducted.
Assalamualaikum warahmatullahi wabarakatuh. For the second procedure, I will be presenting and show how we conduct the compound measurement for perpendicular crack depth for concrete surface using a UV method. So here is the equipment that we will use.
These tests are using an ultrasonic pulse velocity UPV tester, and it is a non-destructive testing. The model that is used is Pundit Lab from Project Switzerland, and the material tested is concrete, mortar, stone and masonry. The features is it is a non-destructive and safe testing method. It has a high accuracy for crack depth estimation, suitable for surface and internal defect detection, can measure perpendicular and inclined cracks, and data storage and analysis for digital models. This testing can be applied to measure the depth of perpendicular crack in concrete, quality assessment of concrete, detection of voids, honeycombing and internal defects, evaluation of uniformity and homogeneity of concrete, and structural health monitoring. And the limitation of this equipment is the accuracy affected by moisture content of concrete, aggregate size and type, and surface roughness. Presence of reinforcement near cracks, assumes crack is fully open and perpendicular, requires experienced interpretation, and not suitable for very shallow cracks.
The objective of this test is to measure and determine the depth of the crack surface on this concrete. before we start the procedure, we must ensure that the surface of this concrete must be clean first. The surface must be clean from any dust, debris or water to ensure that we get the good data at the end of this procedure. Start the procedure, we must ensure that the UPV equipment must be calibrated first by using a standard calibration tools that was provided by the manufacturer, which is for this one is Pundila. After that, the distance points will be marked. So for this test, the minimum measurement point that we must obtain is 50 mm. But for this test, I take 100 mm. So we can start mark by from the crack to the transducer. We take 10 cm, which is 100 mm. From the transducer to the concrete surface crack. So we can mark by using a pen or marker pen for both sides, and we move to the outward for T2 transit time second, which is also 10 cm for both sides. So the total out is 200 mm. After we complete marking the concrete surface, we will use a coupon. This is the example of the coupon gel that we will use. This coupon gel is important to ensure that the transducer and the concrete surface is connected successfully. So we will get a good result at the end of this test. So we can put now for this test at the T1 transit 1 and transit. First, we can start to put the transducer to the concrete surface. First, then press this button. It show 100 meter, 0.1 meter, which is 100 millimeter. So we can press it. Okay, so we got the transit time for first one is 122.8. Continue to the T2. Then we press this button also. So here is the crack depth for this crack. So we continue to the two more different locations because we need to take at least 3 locations for this test. So let's move to the next location.
The data shown the result of the UPV test of perpendicular crack depth. Hi, Assalamualaikum and very good morning. My name is Aidid Muizzudin bin Nazli. Today I'm gonna do half cell potential reading. Half cell potential measurement is a non-destructive testing and detail equipment for corrosion assessment. The model that is used is scanning corrosion analyzer from Project Switzerland, and the material that is tested is reinforced concrete structure. Some of the features of this equipment is it is a non-destructive and in situ testing, simple and quick measurement, high sensitivity to corrosion activities, digital data logging and contour mapping, use standardized reference electrodes. This equipment can be used to detect active corrosion in reinforcing steel, corrosion risk mapping of concrete structures, condition assessment of bridge, building and marine structures, evaluation of effectiveness of repair system, and maintenance planning and durability assessment. The limitations is it does not measure corrosion rate, only the probability influenced by moisture condition of concrete, oxygen availability, concrete resistivity, and presence of surface coatings, requires direct electrical connection to reinforcement, and interpretation depends on experience and site condition. Okay, next I'm gonna show you the equipment that used in the half cell potential readings. This is the COMAC RMP voltmeter. This is the alligator clip. This is the copper sulfate. This is 125mm wetting agent. This is a flask that used to measure the wetting agent. This is the electrode fit inside this bottle. This is the electrode bottle with sponge. This is a 250 feet cable reel used to connect if the distance is long. This is cable reel. This is the still water, same as this used to mix with copper sulfate. And this is the extension pieces. So first we're gonna do the copper sulfate mixture, which is, this is 1/3 the quantity of this bottle. We must ensure that the water is blue and make sure there are still leftover of copper sulfate that not mixed with the still water. Okay, next we're gonna do the mixture of the wetting agent. This is the final result of half cell potential measurement and its readings. That's all from me. Thank you.